Alright guys, today I'm going to talk about two-step experiments and particularly how we represent them using tree diagrams and arrays. So an array is a fancy name for a table, basically. If I think about I'm going to go to the movies and I have 3 movies that I'd like to see, I'm going to go twice. So I'm going to represent the 3 movies here. So Ralph Breaks the Internet, Mary Poppins Returns, or Aquaman. Alright, so here I've represented the 3 possible first movies in my first trial, and then across here I'm going to do the same thing. So Ralph Breaks the Internet, Mary Poppins Returns, Aquaman. So here I have 9 possible outcomes where this box represents seeing Aquaman first and then Ralph Breaks the Internet. Here I see Mary Poppins Returns. Alright, this box here says that I see Ralph Breaks the Internet the first time and then I see it again. And that would be an example of with replacement. And what that means is I'm happy to go to the movies to see it again, so my list of possible choices in my second trial doesn't change. Without replacement, these 3 boxes would be impossible because I can't choose the same thing twice, which is probably a more logical thing in this situation because you're unlikely to go see the same movie twice, especially when there's 2 other movies you want to see. But if we just treat this for now as if I'm perfectly happy to see the same movie twice, this is what an array for a 2-step experiment going to the movies would look like. So I've got 9 possible outcomes. I could write that as a sample space. It would take a little bit longer, but I could. And if it was equally likely that I'd go and see each of the movies, I could calculate, say, the probability of some event that was that I saw Mary Poppins Returns and Aquaman, and that should be represented in 2 places, here and here. I've got 2 different outcomes that satisfy that event, so it would be, the probability would be 2 out of 9 if they were equally likely, which they're probably not in real life. Alright, I'm going to do the tree diagram without replacement, so assuming I'm not happy to see the same movie twice. So I start with a node, and then I've got 3 possible movies that I can see. So it could be Ralph Breaks the Internet, Mary Poppins Returns, or Aquaman. Then I'm drawing another node. I've only got 2 options now because I can't see Ralph Breaks the Internet again. I can see Mary Poppins Returns or Aquaman if I first saw Ralph Breaks the Internet. So if you follow each one of these little branches, you'll find that there are 6 outcomes. And if you look closely, they're the same 6 outcomes as in our array if we excluded the 3 outcomes that included replacement. Alright, so if we didn't include these 3, there are 6 there, and they're the same 6 as here. So you can represent a 2-step experiment pretty easily in both a tree diagram or an array. And now same thing, if I knew that these were all equally likely to happen, I could then calculate the likelihood of an event. So before we said Mary Poppins Returns and Aquaman, I can see that that's this event and also this one. Sorry, that's those 2 outcomes. So that's 2 out of 6. So without replacement, the probability of seeing Mary Poppins Returns and Aquaman is going to be 2 out of 6, which is a third. Now, tree diagrams can get a bit messy when you've got lots of different outcomes. Lots of different outcomes in each trial. So if I had, say, 5 or 6 different possibilities here, this would be very large and maybe easier to represent in an array. But as we get into three-step experiments, as you'll see in the next video, this gets very tricky. So it doesn't matter which one you use for a two-step, it's whatever you prefer. Both are equally useful.